and comments. In the previous chapter, we created strings by placing text within inverted commas. In Python, to assign a number to a variable, use the pattern variable name equals number, as shown in the following example. Height equals 70, or temperature equals 98.6. Okay, and note, if you have a number without a decimal point, that is an integer. If you have a number with a decimal point, that is a floating point number. Python supports both integers and floating point numbers. Integers are numbers without a decimal point, otherwise known as whole numbers. Floating point numbers, however, will always contain a decimal point. The data type for integers is int, while the data type for floating point numbers is float. Numeric operations. The Python interpreter is capable of performing several operations using numbers. These are some commonly used numeric operations. We use the symbol plus to add, dash to subtract, asterisk to multiply, slash to divide, two asterisks to exponentiate, which is raising to the power of, and the percent sign to do a modulo operation, which is the remainder after dividing. And we'll see some examples now. You're most likely familiar with the common symbols, plus and minus. As with most programming languages, asterisk, and we sometimes call this star, is the multiplication symbol, which is normally a cross in math. Slash is the divide symbol. Okay, that's the normal divide symbol in math. Two asterisks or two stars is exponentiate. For example, 2 star star 4 means 2 raised to the power of 4, or 2 to the 4 in math. The equivalent to this is 2 times 2 times 2 times 2. Okay, when you raise 2 to the power of 4, you're multiplying 2 by itself 4 times. And that is equal to 16. Percent is the modulo operation, and that's normally written x mod y in math, and that returns the remainder after dividing. For example, 3% 2 is 1 because 3 divided by 2 is 1 with a remainder of 1. 4% 2 returns 0 since 4 divided by 2 is 2 with a remainder of 0. And just by the way, in general, modulo arithmetic is done using non-negative integers. It gets quite confusing with negative integers. Okay, so here we've got a Python program. We set the variable sum equal to 3 plus 2. And that will give you an integer because these are both integers. And when you add one integer to another integer, you get an integer result. Difference equals 88 minus 2. And that again will give you an integer. Product equals 4 star 2, or 4 times 2. Quotient equals 16 slash 4, or 16 divided by 4. Power equals 3 to the 5, 3 to the power of 5. Remainder equals 7 modulo 3. Okay, so then if we print sum and we format the variable sum, and then difference with the value of difference, product with the value of product, quotient with the value of quotient, power, and print the value of power, and remainder, and print the value of remainder. That will give you this output. Sum is 5, difference is 86, product is 8, quotient is 4.0, product is 243, and remainder is 1. Okay, let's try this in Python. I'm going to open a command window. Okay, so this is a command window. I'm going to start Python by typing Python. Okay, it says Python, that's version 3.7.3, and we're at a Python prompt here. Okay, so let's try that code. If I type in that first line. Okay, you don't see anything happen, but it's created a variable called sum, and it's equal to 3 plus 2, so this is an integer variable, and it's equal to 3 plus 2. I'll just put in all the rest of the variables. Okay, so it's created difference and set it equal to 88 minus 2. It's created product and set it equal to 4 times 2. It's created quotient equal to 16 divided by 4. Power equal to 3 raised to the power of 5. And remainder equal to 7 modulo 3. Okay, so now I'll print each of these. Okay, so I say print sum and curly braces, and we format the variable sum. So sum was equal to 3 plus 2, so it's 5, and that is an integer. Okay, print difference, curly braces, and formats the value of difference. Difference is 88 minus 2, so the value is 86, and again, it's an integer. Prints product, and the value of product, it's 8. Product was 4 times 2, so 2 times 4 is 8, and that's an integer. Print quotient, and value of quotient, it is 4.0. So this is a float, and the reason that it's a float is that whenever you divide two numbers, whether they're floats or integers, the result is always a float. Okay, power, value of power. Okay, it was 3 to the power of 5, so that's 243, and that's an integer. Okay, remainder, formats the value of remainder. Okay, the remainder, whenever you divide a number and take the remainder will always be an integer. So you can see here that the value is an integer. Okay, let's go back to the slides. Okay, take note that even though the result of 16 divided by 4 is the integer 4, the floating point number 4.0 was displayed in the output created using the example in this code. The division operator performs floating point division and will in every case return a floating point number and not an integer. Also be aware that if you add an integer to a floating point number, the result will always be a floating point number. Okay, here's some more examples. The following example demonstrates the capability of Python to perform mathematical operations using variables. So again, we got sum equals 3 plus 4, difference is 200 minus 2. New number equals sum plus difference. So we've got a new variable and we're setting it equal to value of sum plus the value of difference. So then if we print new number, print sum divided by sum, and print sum plus 1, we get 205, an integer. We get 1, which is float, because if we divide, even if we divide integers, we always get a floating point result. And sum plus 1 is 8, which is an integer. Okay, let's try this in Python. So I'm going to go to the command prompt again. Okay, and you'll notice that everything is still here in my command prompt. Now I'm trying something new here. It's a new program, so I want to get rid of all of this. And the easiest way to do that is we'll just get out of Python. And to get out of Python, you press Control and Z, and then press Enter. Okay, you'll see you're back in the DOS prompt here. So now if I type Python, I'm back in a new Python environment. Okay, so I'm going to take all those variables, so sum was 3 plus 4, difference was 200 minus 2. So new number, I've created a new variable, and it's equal to sum, which is the value of sum, plus difference, the value of difference. And now I'll print each of those. Okay, so I print new number, and that shows us 205. So new number is equal to 205, which is sum plus difference. If I print sum divided by sum, it's 1.0. Again, that shows that it's a float. Okay, because whenever you divide, it always gives you a floating point result. And print sum plus 1, that's sum was 7, so 7 plus 1 is 8, and that's an integer. Okay, whenever we're done with Python, we can always quit. So it's Control Z, enter, and we're back at a command prompt. Okay, strings and numbers. The following example creates a variable named quantity and assigns it the numeric value 4. It also creates a variable named quantity string and assigns it the string 4. So quantity equals 4, so this is an integer variable. And quantity string equals 4 in inverted commas, so this is a string variable. So keep in mind that if you try to perform a mathematical operation against a string, you will encounter an error. Try to be aware that if you surround a number with quotes, it will become a string. Okay, so we had quantity string is 4 in inverted commas. So if we say total equals quantity string plus 1, we get an error. It will say it can't convert an int object to a string implicitly. Okay, let's try this in Python. We created a string variable and a numeric variable. Okay, but you see here I'm saying total is equal to quantity string plus 1, but this is a string. So what happens when I press enter? It says error, can only concatenate a string, not an int to a string. So it's trying to add a, it thinks that one is supposed to be a string that you want to concatenate to this string, but because it's an integer, it can't do it, so you get an error. So instead, we need to convert to an integer. Okay, so here instead of having total is quantity string plus 1, we say it's function int quantity string plus 1. So that converts this to an integer, adds 1 to it, and when we print the total, we get 5, which is 4 plus 1. Okay, and again, I'll quit. Okay, so the int function, to convert a string into an integer, use the int function and pass in the string to convert. So we've got quantity string equals 4, so this is a string variable. Then we've got total is equal to int quantity string plus 1. So int converts quantity string into an integer, and then we add 1. And when we print the value of total, it gives us an integer 5. Okay, the float function. In order to convert a string into a floating point number, use the float function and pass in the string to convert. So quantity string equals 4, so that's a string. Quantity float equals float quantity string, so now that's the float version of that string. And then we print quantity float, it will print 4.0 because that's a floating point number. Okay, let's try that in Python. And this was just like the int function, but now we're creating a float. Okay, so we've created a string variable, set it equal to the string 4. We convert the string to a float, and then we print the float, and now you'll see that it's 4.0 because it's a floating point number, not an integer anymore. Okay, comments. Comments give you a way to document your code. For example, a comment can help summarize what is about to happen in a complex piece of code. This can be incredibly helpful if you or a fellow programmer need to look at the code at a later date. Using comments can quickly explain what the intention of the code was at the time it was written. Comments are ignored by Python. A single line comment is prefixed with a hash. This is a comment. Python simply skips comments. A comment can follow Python code on the same line. So here we've got a line of code, remainder equals 7 modulo 3, and then there's a hash, and everything after this is a comment. So Python ignores this. Another option is to create multi-line comments by using triple quotes. You can use either single quotes or double quotes. The comment will begin directly after the first set of triple quotes and will end directly before the following set of triple quotes. So here we've got triple quotes, then the comment starts here, the comment is another line in the comment, here's the last line of the comment, and then we end with triple quotes. Or we can do it this way, we have triple quotes on its own line, then this starts a comment down here. Python will not attempt to interpret these lines as they are comments, and then these triple quotes end the comment. So this is a good way of putting a heading on a page or a heading before a function or a piece of code that you want to explain. If we go back to our pig speak exercise in the previous chapter, you can practice adding in some of your own comments to make your code clearer. So here we've added a comment, get the input from the user. So text equals input. What would you like the pig to say? Here's a comment. Determine the length of the input. So text length equals length text. Make the border the same size as the input. Okay, so we've just added comments to each piece of code to explain what it does. Okay, so let's review what we've gone over in chapter 2. Unlike strings, numbers require no special decoration. When you enclose a number in quotes, it will become a string. Use the int function to convert a string to an integer. Use the float function to convert a string to a float. A hash will begin a single line comment. Multi-line comments can be enclosed with triple quotes. Otherwise, start each line with a hash. Okay, so we'll try an exercise. So calculate the cost of cloud hosting. In this exercise, let's assume that you are planning to build a social networking service using your new Python skills. You make the decision to host your application on servers running in the cloud. Once you've selected a hosting provider, you want to know how much it will cost to operate per day and per month. You will launch your service using one server, and your provider will charge R1.02 per hour. Try to write a Python program that will display the answer to the following questions. How much will it cost to operate one server per day? And how much will it cost to operate one server per month? Okay, so let's take a look at this. Okay, the solution, the following is one way to use Python to find the answers to the preceding questions. Take note of the fact that comments are used throughout the code. Also, while this is one possible solution, keep in mind that there are multiple ways to go about solving the same problem. Okay, so you see we're commenting on our code. We start by saying, comment the cost of one server per hour. Cost per hour equals 1.02. Compute the costs for one server. Cost per day is 24 times cost per hour. Cost per month equals 30 times cost per day. Then display the results. Print cost to operate one server per day is R, and then in our curly braces, we've got 0.2f, so that's going to be a floating point with 2 decimal places. And that's the cost per day. The cost to operate one server per month is, and again, formatted, cost per month. So the output is going to be cost to operate one server per day is 24.48. Cost to operate one server per month is 734.40. Okay, and sorry, these should be on two separate lines. Okay, let's try this exercise in Python. And let's first clear this out. Okay, we'll start with our comment. And one thing about the interpreter is that it allows you to carry on with comment on the next line. So you have to press enter to show that that's the end of the comment. Okay, we set our variable cost per hour. Comment is compute the costs for one server. You press enter. So cost per day is 24 times cost per hour. Cost per month is 30 times cost per day. Comment is display the results. So we print cost to operate one server per day is, and we're going to format with 2 decimal places the cost per day. So it will display cost to operate one server per day is 24.48. Then we print cost to operate one server per month is, and now it's going to be the value of cost per month. So cost to operate one server per month is 734.40. I just want to show you a completely different way of running a program. So let's get out of this. In this folder, I've created a file called exercise1.py. This is our program. If we take a look at it, you'll see this is what it looks like. We've got the comment, we set cost per hour, another comment, cost per day, cost per month, display the results, print. So I've created a file called exercise1.py. I can run this program simply by typing Python and the name of the program, the name of the file. And notice what happens. It simply displays the output. Cost to operate one server per day is this. Cost to operate one server per month is that. Okay, so this is the most common way of running programs. We create a program, put it into a file, and then we run the file using Python. So in that case, we'll see then that the comments work to show you what your code is meant to do. Okay, so that's different from in the interpreter, where when you type a comment, it wants you to continue to the next line. So here, the comment is simply displayed without being executed. Okay. Okay, calculate the cost of cloud hosting continued. Building upon the previous example, let's add some more information. Assuming that you have saved 1,836 Rand to fund your new business venture, you're now wondering how many days you can keep one server running before your money runs out. Ideally, though, you are hoping that your social network becomes incredibly popular and ultimately requires 20 servers to keep up with the demand. So factoring in this information, how much will it cost to operate at that point? Okay, so you can do this problem. Just think about what needs to be calculated. And now I'm going to skip over the results, but you can pause to look at the results after you've tried doing this yourself. Okay, so this is the end of chapter 2. The next chapter is going to be chapter 3, Booleans and conditionals. So we'll see you then.